Hey guys, welcome to the new devlog for the game I've been working on the last few weeks. But before we get into any of the details, some of you who've been watching this channel recently might be wondering who is the guy who's actually talking right now. I'm obviously not the same person who's doing the Fahrenheit devlogs, which I can definitely recommend to you if you like retro games. EndRealm is a group of hobby developers that like to make games and projects and collaborate together on those projects, which would otherwise not be possible due to limited time and other factors. This game, on the other hand, is gonna be a 2D platform roguelike, similar to Dead Cells and Skul, which I absolutely loved, but with some unique mechanics, specifically targeting late game expansion and progression. One of the fundamental mechanics in the game is a train. It acts as a hub before runs and between levels. As the train will drive through different areas, we have the requirement to create different parallax background themes, which have to be dynamically loaded and adjusted to the train speed, width, and other parameters. This means we need a modular and dynamic system for loading parallax backgrounds. Now let's jump back into Unity, and here we can see a scene for the train hub basically, and once I press play we can see how it looks in game. So currently this is all prototyping. The character is just prototyping to see animations in action. They're terrible animations, I know, and the trains and the wagons are also just prototyping assets, of course. So in here we see that there is a locomotive at the beginning and then different passenger wagons. Those are automatically generated, and I can run through here freely, just jump a bit in here. And what we want is a moving background. So we have two types of backgrounds, those further in the back and those closer to the front. The ones in the back have to be attached to the camera so that the movement of the player will not influence them or their position relative to the camera. The ones in the front will be attached to the train so that the player movement will actually influence them. Instead of moving the train, we're going to move the backgrounds. This means that the background pieces here will move along with the camera, and then once they reach the end, they will be teleported to the beginning. The trees, on the other hand, or tracks or whatever, will be moved along with the train. They will also be scaled along with the train, so they will only be rendered on the train length with a padding or a margin on the left and the right side, of course, so we stay inside of the camera bounds and it doesn't just cut it off. We also want to allow random variations, because just having the same sprite just being rendered over and over again would be boring. So it would be great if we would have some kind of a way to allow configuring a weight for each individual tile in, let's say, a layer, and then allowing random variations. But before we can do that, let's create the backgrounds, pieces, and parts. Here we are with the power of video editing. We just skipped a lot of time and have the different pieces ready for our use. At first we have simple train tracks, then ones with red flowers, orange flowers, and those are the track variations. Then we have poles, which is some kind of power pole line, which creates a different offset and a bit of depth for the scene. We have different variations with 1 crow, 2 and 3 crows, and one which has a broken down connection. As you can see, this one is bigger than the others. So our Parallax system will have to take that into account when assembling those pieces. And here we have the mountains, which is some kind of panorama background, which we're going to use. I reused this from an older project and just adjusted it so it works out the way I want it to work in my scene. At the bottom we have the mountains and the clouds. Later on we might just split that in multiple layers so it's easier to create more depth. And it may look a bit cooler than the way it would right now. But we're just going to implement it now and then later on see what we can do to improve the look. Then, of course, we have the trees and the ground layer. So let's hop into Unity and see if we can assemble those in some kind of a parallax background system. So now, after another cut, we got the scrolling background system. Let's take a look at the code. If you're not interested in the code, I'm gonna add a timestamp below where you can skip to the in action or the in Unity part and see the system in action. We're not gonna go too much into the technical details of a Parallax background system. There's a lot of YouTube tutorials out there which explain how to do this. I do like this system specifically because it allows to create different variations of different size and also giving them weights, which is something I find really important to help make it less monotonous. In Unity, the different pieces will be reassembled as game objects and be saved as prefabs. On these prefabs or game objects, there has to be a background piece behavior script, which defines how wide it is, so the pieces can be properly assembled. It also defines the weight of the individual pieces. From the perspective of the scrolling background, these background pieces will be wrapped by piece instances at runtime to allow exchanging background piece classes later on in some kind of modular way. We don't need that right now, but it's simpler for me to do so, and that's why I added them from the beginning. On start, we first have to fill the remaining space with pieces so that the pieces don't just start scrolling in from the right side, but are also already present when the game begins. This is handled by the setup method, which basically adds a piece, shifts it to the left, and then calls add new, which automatically shifts left. This is done in this case because we need to shift to the left side of the screen, and the add new will only shift to the most left piece of that row. So once we got the setup done, we can look at the update. At first, we check if the most left piece is visible. As soon as it is, we spawn a new piece. This is so that there is no seams when a new piece moves in from the left side, and that there's always a piece on the right side out of the screen, because current system only allows movement from right to left. This could obviously be changed to allow movement in the other direction by just checking in the other direction, but for right now it only allows right to left movement. Once we know there's always one on the right side, we go through every piece and move that by the speed factor. Once a piece is out of bounds, we're gonna remove it and return it to the pool so we can later pick it out of the pool. Now the only thing left to do is add pieces and select pieces. For that, we have to calculate the total weight, select a random number between 0 and the total weight, then add until we find the piece which is actually in that weight range and return that. Adding a piece, on the other hand, is quite simple. We take the prefab instance we get, or rather the background piece we want to have, and then we tell the pool to either give us a game object of that ID or create a new instance. Then we take that instance, which is either pooled or not, and create a new piece instance with that. Then we teleport it to the start and add it to our active pieces list so it gets updated and on move. In Unity, we now only have to create the prefabs for all the individual pieces. For example, this one is pole 5. It has a texture on there with some kind of order and a background piece. I added some kind of gizmo so we can see the width which is configured over here and a weight of 4. The weight was just defined by random testing and not some kind of sophisticated mathematical method. I was just trying out random values until I liked the patterns. Inside of the scene, we now only have to create a scrolling background, add all the parts, set up the object pool, add a speed multiplier, and configure a width. I also added a small background resizer script, which basically changes this width to be the train width, so that the pieces are actually as long as the train. This resizer also recenters this piece due to the scrolling background always considering its own origin as the center of its animation. So the width will be 7.5 in both directions, and that won't be the train because the train starts at 0, 0 and then moves to the left. So we got to recenter this as the train changes its size. For the background layers, so the ones which are far in the back, we have a bit of a different type of style. We also have the background resizer, but we also have a background follow camera script. This just hooks into the Cinemachine, the virtual camera, and locks to the X. It also resizes to the camera orthographic bounds in world size, so that the scene is not just cut off in here, but is also always centered and has the correct dimensions. Now, of course, we can hit play and everything will work out. As you can see in this scene, we have the backgrounds, they are moving parallax and they are scrolling infinitely. The background in the far back isn't moving with the train, but with the camera. So the player movement does not change how this moves relative to your position, because that wouldn't make sense as it's far in the back officially. Then the ones close in the front obviously are affected by the movement because they are relative to the train itself. If we look in the scene, this is how the system looks in action. It also always takes the train width in consideration and then moves them in, and it's always one piece outside of the vision. And the background here is always relative to the camera, as you can see. Now the only thing left to do is create a proper theming system, because right now I have to hard code these layers, and some themes might have more layers or less layers or different layers and so on. So what we need is a way of dynamically loading those into the scene and attaching them to the speed control, which is in charge of managing the speed on a central position, and to the train, obviously, because those pieces have, or some of the pieces have to be resized. Also, the panorama layers have to be attached to the camera. So I went ahead and made this modular, and with the power of editing, we're again back and have all the heavy lifting done in just a brink of a second. Then over here we have a background theme system and a test theme loader. This will later on be replaced by some kind of sophisticated theme loader, which is in charge of loading depending on where you are at in the game. So over here, the theme manager will take a theme delivered by a theme loader and load that into the game. Let's take a look at the theme. It's a scriptable object that takes all kinds of layers as a parameter. A layer is basically just a wrapper for a prefab, because in here we can later on attach more data if we need so. What the system does, it automatically detects the scripts which are placed on the different layers, for example this layer over here, and depending on that it will automatically wire it or hand it what it needs, wire it up to the train or wire it up to the camera and so on. So once I hit play, as you can see, it will add all of the layers over here with all of the tracks and its pool of unused objects. And here we go. I also added invulnerability frames, and they're going to be displayed over here. If you roll, the life bar is going to go blue. But that's not very important right now. And as you can see, we now have a themable Parallax background system, which we can use to create lots of parallax scenes for the train. Later on, we're of course gonna add more textures and improve the textures. These over here are basically just for prototyping and for the first versions of getting a feel for how the game should actually look. And I'm thanking you all for watching and hope you subscribe and wait for the next video. And don't forget, if you're interested in retro games, look at the Fernweh devlog. I'm gonna link that somewhere in the video. I don't know where, but you're gonna see it.